2.3 variables and literals. Literal, by definition, is just a value, and it could be part of the variable state, or it could be standing alone. So for example, we say 2, 3 of an integer, that's a value. But an integer variable can contain different state of values at different time, and that's why we call it a variable. And so those are the there's a relationship, and at different stages of the program, the variables will be reassigned, and the reassignment could be coming from another variable state, which is the value, a particular value, and copy into, overwritten your current value. All right, so that's what it means, and let's examine this particular segment of code, variable.java. And in here, we actually have a initialization here. So this is called declaration, and it hasn't been initialized. The initialization normally requires a assignment operator, and this is called assignment operator. Equal sign is assignment, and we are assigning a literal, meaning it's an integer literal, so it's one of the state, 1, 2, 3, 4, 5. We happens to be 5, and we are going to take this and put it inside the value variable. All right, so it's a little bit convoluted, and then those next two lines you understand. So it means that we are going to put a header string called the value is, and then print out the value variable at that particular moment. That will be 5. So the output is this. So the output is right here, this one. That's the output. All right, so and I have just went through the definition here, and let's take another example. So the value is also started as 5 and assigned the literal integer value of 5. And what we have here is we have this thing, and that is a quoted text string, and double quote enclose a string literals. So it's a value for the string type, and the value happens to be value, and that's why it's printing out not 5. It's printing out a string literal as opposed to be a integer variable. So value here is not an integer variable but a string literal. That's what it means. Okay, so that's another example, and we have a very interesting concept here, that different data type, they have similar type of operation, and we share the plus operation for the string types as well as the integer or other number variable type. So when we have 1 plus 1, it equals to 2, but if this is plus 1 string, we combine them together. So this read or output as this is 1 string dot. All right, so that's what it means, and the printout will be like this. And so that's just the operator plus. And here we said that we have an error, and it's just because the quotations opening and closing right? So to be precise, this is opening here, and this is closing. So that there is a intrinsic, meaning built-in limitation of the quotations for making it as a literal. And what it is that this opening and closing has to stay within the same line. So when you cross lines, that you are going to introduce a control character, and that's not part of the permissible definition of a string literal. It's a control character. It's not a regular character, so you cannot do that, and that's the reason. All right, but the expression here, so this is an expression. I'm just saying that, and the expression can take it across the line because we are able to concatenate that in multi-line mode, because the expression always goes pretty long, so you need to cross the line boundary, and the compiler knew about it. So it's not a string literal, it's a whole bunch of string literal ended and combined together. So this is what this couple of paragraphs are talking about. All right, and be careful with quotation marks. And so when you quote letter 5, it is a string. So the value, if it's an integer, then you are assigning the string to an integer. And again, Java is strong type. You cannot mix them. In other languages, you can do that. It's called implicit casting. Casting means you are forcing different types together. And there are implicit rules that you can do that. But in Java, you cannot do that. You have to be either converted after you convert it or force conversions. All right, so that's what this one means. And more about literals in this particular example. And by the way, you can test them yourself. All the source listings are in the GitHub. So bring it out, put it on your PC, Mac, Linux machines, and play with them so you get a better understanding. So this one here is that we have both the literals and variables. So this is the variable. We have the apples, which is an integer, 20, and we can combine them because this is what we are talking about. If you use an assignment, you directly forcing one to the other. But if you're using a function, what it does is just interpret that to the value of the printout. So everything in the print or print line, all these arguments are going to be translated into text string. Even it's an integer, it's going to be printed on the console device. So it's going to be shown here, right here. This is a console device. And we have this text string right here up to this point. And then we print out 20, and which is a string. So whenever we have a integer or number things, this particular print line function is going to convert those variables into string. That's why this one works. Okay, next, literals. So this is just a check. So we say, is 20 a literal? No, 20 is an integer. So literal 20 is an integer. All right, so this is a little bit difficult to see, but if you know the context as we come along, then it's easy to understand. But just out of context, you're looking at that, it's confusing. And I hate this kind of test, but at some point we have to do this. And the reason is once you get used to the programming, you will have these built-in sensories. Okay, so identifier. Identifier is programmer-defined keyword. Well, let's not use keyword, defined name. And it represents certain parts of your program. And so we have int here is a keyword of the data type, and you can choose your representation of that particular integer, and that representation is identifier right here. That's the keyword, identifier. So you choose X as the identifier, and next one is item ordered as identifier, and so on. You can choose anything you want. Now, what we are going to talk about is identifier, meaning the variables or whatever that you are going to be creating. They are only the alphabet, uppercase and lowercase, and digit, and 2 special characters that you can use for your identifier. The other 2 is underscore and the $sign. All right, so, and $sign is special because you can use the $sign anywhere. And so why we use that? We use that for special occasion, and that is up to the programmer or the team decided what's the convention you are going to use. And so these are the rules, and you cannot include the space because space is a terminator. It's one of the terminator of the identifier declarations. And so here it's saying that the $sign is a legal identifier, but it is normally used for special purpose. And what is special purpose? It's defined by the public. It could be a small development team, or it could be a general forum that you go to some kind of association and you agree with this particular convention. So there's no formal building into the compiler. This is just a convention. All right. So here, this is syntax. So go through this and make sure that you understand everything. So it's pretty obvious that if you have the pound sign and you have the space is a terminator as well. So that must be illegal. And the other ones that go through them and make sure that you understand. Class name right here. Class name has specific rules that and this rule is not by the compiler. This rule is not by the compiler. As mentioned before, it is standard practice to begin variable names, right? So that's a practice for the variable name as a lowercase letter, and then capitals the first letter of each subsequent word, and we call this as camel casing. It's like a camel. You have bumps, except it has a lot of bumps. If you use 3 words, you got 2 bumps, and so on. And the next statement is, it is also standard practice. That means it's a practice. It's not a compiler. Compiler don't care about whether you capitalize it or not. But in practice, we do, because we want to differentiate what is the named item by of the keyword, such as the class or the method and so on, how you're going to shape it. But we only capitalize the first character for the class as a standard practice, not by the rule of compilation. All right, so I'm going to end my section 3 talk here, and we will go to the next one, and I'll see you there.